All right, in this video presentation, what we're looking on is some transformation questions. So here we're looking at this question that says, the diagram below shows a triangle PQR and its image P prime, Q prime, R prime. So we're looking at this. So if we look closely, we would have seen two triangles on our screen. All right, so PQR is actually this triangle here, and P prime Q prime is this triangle here. So definitely we're observing those. Let's see what the question says. It says state the coordinates of P and Q. All right, so this, remember, whenever we're reading coordinates, we're definitely going to be reading the X value followed by the Y value. And the X value would be on the X axis. So P, so looking at P would have been 2 linking with this. And this is how we would have gotten P right there. So based on what we have, we could fill out some numbers. For example, this is a number 1, then 2, then 3. And then on the X axis, there is a 1, 2, then 3, then 5. So we could fill out those missing spots. So then the coordinate for P, as you could see right here, is a 2, 1. So remember, we read the X values first, then the Y value after. So the coordinate of P is 2, 1. All right. They want us to read the coordinate of Q as well. So let us identify Q. That's where the point Q is right there. But we could see it's 4 from the X linking with 3 from the Y. So then the coordinate of Q is 4, 3. So we could write it here. Q is 4, 3. All right. So those are the coordinates there. All right, so outside of the coordinate, we are supposed to describe fully the transformation that maps triangle PQR onto P prime, Q prime, R prime. Now, there are a few transformations that you want to think about. There's a dilation, or what we call enlargement or reduction, which means that the size would have been changed. When we look at this, we realize that the size was not changed, so it's not a dilation. A translation is the transformation that does not flip or turn the image and the object, or the image. What it does, it just changes the location and the orientation of the image, and the object would be the same. This is very different, right? A rotation employs turning. So you would have seen where the image is actually turning the clockwise or an anti-clockwise direction from the object. We're not seeing that. But what we're seeing here is a reflection. So for every reflection, there is a mirror line, and then you'd have to look for corresponding points. For example, P would correspond to P prime, Q would correspond to Q prime, and R would correspond to R prime. So we're going to observe those to see if we can find anything. So when you look closely at P and P prime, you do realize that if we focus on this line that I'm going to put in green here, this line is basically an equal in distance. It is actually equal in distance from the 2 points, which is suggesting that this is the mirror that we're looking at. All right, so the mirror is the x-axis. So the mirror is the x-axis, so we're looking at that mirror, the x-axis right there. So because the mirror is the x-axis, then we are reflecting. So this is the mirror line. It is the x-axis. So we're reflecting in the x-axis. So you could see here as confirmation that P is 1 unit above the x-axis. So the corresponding point, which is P prime, fell 1 unit behind or below, all right, the axis. Let's check Q. Q is 1, 2, 3 units above the x-axis. So its reflection would fall 1, 2, 3 units below. I'm going to check R. R is 1, 2, 3 units above the x-axis. Its reflection would fall 1, 2, 3 units below. So definitely we could see here that the transformation is a reflection. The transformation is a reflection in the x-axis. Right? So it's a reflection in the x-axis, and we have gotten 2 marks to identify that. We're going to write down the coordinates of the image of P and Q under the translation 3, 6. P and Q. So here we have them. Remember though, the principle says that an object plus translation gives us the image. So we're going to embark on this idea. But a translation is always in a vector form. So the translation is in a vector form, which means that we're going to have to represent our points in a vector form as well. So quickly, let's look at the point P. The point P, I'm going to write it in a vector format, 2, 1, plus the translation 3, negative 6. Adding matrices, we're looking at 2 plus 3, then 1 plus negative 6. The image will be 5, negative 5. So that's the image P prime. All right, 5, negative 5. Now for Q, Q in a vector format is 3, 1, 4, 3, should say, plus the translation, I'll put T for it, 3, negative 6. And if we should add this, 4 plus 3, 3 plus negative 6, and we're looking at 7, negative 3, and this would have been Q prime. But remember though, we're not just going to leave it like that. It did say the coordinates. So coordinates cannot be written in a vector format. So let's write the coordinates. P prime is 5, negative 5, and Q prime is 7, negative 3. So there it is for that one. Let's focus on the other question. Another question, another transformation question. It says the diagram below shows the triangle RST and its image R prime, S prime, T prime after a transformation. All right, so we're looking at the transformation there already. All right, so let's see what the first question says. The first question says, it says, write down the coordinates of R and R prime. So let us write down the coordinates of R and R prime. All right, good. R and R prime. We could quickly write them by the side. So we're talking about identifying this point here, R and R prime. So definitely looking at R, we could see that it's this point where this X value here means that on the Y. So I'm talking about 2 on the X with 4 on the Y. This is a 2 here, right? It is a 2. So 2 on the X meets 4 on the Y right here. So 2, 4. So R is 2, 4. R prime, as we could see here, is simply looking at the X. R prime would be 2 on the X, which means 0 on the Y. So it's a 2, 0 for R prime and a 2, 4 for R. All right. All right. So let's now look at the next question. Question says, describe completely the transformation which maps triangle RST onto triangle R prime, S prime, T prime. So we're looking at the second question here, right? So I want to know what transformation maps this triangle up top. Let me just put a quick shade on it. This triangle, we want to know what transformation maps this triangle onto this triangle. All right. All right. What transformation maps that triangle onto that triangle? So let's look carefully. Again, you could quickly eliminate some transformation like enlargement or dilation. We're not seeing where there is a change in size. So definitely it's not dilation because there is no change in size. So we want to eliminate that. So it's not a dilation. Translation either, because when you translate, the object would have set just as how the image would have set. The orientation would be the same. So we're not seeing that. You could see that there is some flipping and there is some changing going on. All right. The reflection will change the order of the points. Clockwise order turn into an anti-clockwise order. For example, RST is going in this direction. RST is going around like that. RST. And then no, so this is RST is going in a clockwise direction. But if you look on the image for it, R prime, S prime, T prime is going the opposite direction. So it's going in an anti-clockwise direction. So the object up here is going in a clockwise direction, while the image is going in an anti-clockwise direction. So we are suggesting that the reflection does that. It's laterally inverted. So then it is a reflection. No, it's the mirror line. All right, so let's look for the mirror line. The mirror line is midway between any two corresponding points. The points that are corresponding are R with R prime, S with S prime here on the y-axis. And this is splitting the justice. So I'm seeing here where this is my mirror. So let me just drop my mirror line here. Y is equal to 2. So where Y is equal to 2. So at Y is equal to 2 right here. We could see at Y is equal to 2. This is our mirror line. So I'm going to put the word mirror on it. And then, yeah, I'll just write mirror line. So the mirror line is Y is equal to 2. And we could navigate now. For example, let's look. R is 1, 2. All right. 2 units above Y equal to. So R prime will fall 1, 2 units below R prime, Y equal 2, and we're seeing that. Let's look at T. T is 1, 2, 3 units above Y equal 2. So if it is a reflection, it's going to fall 1, 2, 3 units below to find the image for it. And we're seeing that. S is 1, 2, 3, 4, 5 units above the Y equal 2, which is the mirror. So it's going to fall 5 units below Y equal 2. So it's 1, 2, 3, 4, 5. So we're seeing where everything that we're thinking of is matching up. So we will agree that this is a reflection in Y equal 2. So it's a reflection in Y equal 2. So let's respond to that question quickly there. So, so this is a reflection. All right, so it's a reflection in the line Y equal 2. Now let's go to the next question. So it says RST undergoes an enlargement, center 0.4 and scale factor 3. All right. So RST undergoes an enlargement. We're right here, with center 0.4, all right, and scale factor 3. So very importantly, an enlargement, the center 0.4. So 0.4 is right here. So let me just highlight the center right there. So 0.4 is right there. Before we start doing that, we're gonna create a framework for what the enlargement will fall on. All right, so we're going to do this enlargement here. So what we want to do, though, is to understand that there is a line that passes through the center of the enlargement, which is 0.4 right here, my yellow spot. And what that is going to do is that there is a straight line that passes from the center through the vertex or the vertices of the shape that we're dealing with. And there is a straight line that will pass through the center of the enlargement through S, and it's going to pass through S double prime or prime prime. There is another straight line from the center through T, will pass through T prime prime as well, and from the center through R prime prime. In other words, there is a straight line that connects the image to the object from the center. Hence we have that, and that. We can employ some quick counting though. For example, I decided that I want to count this. So let's do the counting from the center. So we could use all sorts of methods. Watch this. You could look here from the center here, right here. R is 1, 2 units away from the center along this line. So if you could think of a scale factor of 3, it's going to triple the distance from the center to R, from the center to R double prime. So triple this up. 1, 2, go again, 1, 2. So we're expecting R prime, double prime, to be 6 units away from the center. If R is 2 units from the center, then R double prime will be 6 units from the center. 2 times 3 gives us 6. So the scale factor will triple the distance from the center as well. S, look at S, we could count S in a number of ways. I could count S in a number of ways. For example, I could say, let's look at counting across these diamonds here to it. For example, I'm looking at going diagonally. I'm seeing 1, 2, 3 diagonal. So I'm going across to S. It's going to give me 3 times that, which is 9. So that is 3, 4, 5, 6, 7, 8, 9. And I'm certain that this is where S double prime will be, right there. S double prime is right there. T. Look at how I get to T here. You could see that I move 1, 2, 3, 4, 5 places to the right. I'm moving from the center and 1 up. So I'm actually using a translation vector 5, 1. So if I move from the center 5 to the right and 1 up, if you multiply this by 3, you will get 15 and 3 up. And definitely it's gonna, if I count 15, so I'm gonna count 15 to the right and 3 up, and it's going to land me at the exact spot. So this is already 5, all right? So we're talking about 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 3 up. 1, 2, 3. Exactly here is going to be my T double prime. So there are various ways we could get there. You understand? Because the thing is with the scale factor is that it is actually tripling everything that the object has or had. All right. So every single thing that the object has, it's going to triple that as it relates to the image. Hence, now we could just recreate and draw our new thing. All right, good. So as soon as we have identified our spots, and then you could see what the concept that we're referring to, that there's a straight line that passes through the center of the enlargement to each point and its image. So for example, talking about from center to S prime, there's a line, that straight line, from center again to T double prime, from center to R double prime. There is a line, a straight line. So already you know that it's going to be on that line. So you could draw that line and then use it as confirmation or help you towards your counting. I'm just going to, if you just look at this, you could see that everything triples, all right? The ideas triples. For example, if you look at, I'm just going to highlight one thing that tripled right here. If you look at ST, it crosses two diagonals like that. And that means S double prime, T double prime would cross 6 diagonals because it's going to triple. 2, 3, 4, 5, 6. So you can see that distance tripled as well. And everything is like that. All right. So that is how the scale factor affect the things. All right. Good. The area of the triangle RST is 4 square units. All right. So we're told that the area of RST is 4 units. Calculate the area of triangle R double prime, S double prime, T double prime. All right. So we're told that the area of this, let me point to it. The area of this is actually 4 units. All right. Bear in mind that the area of an enlargement is affected by the scale factor. All right. So here is the thing. Here is the thing. Area divided by object area gives scale factor. I'm going to call it K, but it's not K. It gives the scale factor square because we're in the dimension of area. All right. So then this is something that we could use to help us. All right. So what that means then is that we have information already because we were told that the object area was 4. So let's look at this. So the image area is what we want. All right. So the image, let me write what the image is. The image is R double prime, S double prime, T double prime. So we want the area of this over the object area was 4 units. We got that. And it's equal to the scale factor square, and the scale factor is 3. So we're looking at this idea. The simple mathematics. We multiply both sides by 4. We multiply both sides by 4 here. So basically what we're suggesting is we multiply both sides by 4. So that you could see that this cancels here. So then we're saying that R double prime, S double prime, T double prime area is equal to 9 times 4, which is 36 units. A lot of people might have thought that 12 would be 4 3 12. No, when we're dealing with area, the scale factor must be squared in order to go to that dimension to sort out that. All right, good. So we're getting here that this is 36 units squared. Next, Next, state two geometrical relationship between triangle R, ST and R double prime, S double prime, T double prime. We are just going to state the obvious here. Two geometrical relationship. Now, definitely, number one, we could use scale factor to do it. Using the scale factor 3, we could say the length of the sides of R double prime, S double prime, T double prime is 3 times longer than the length of the sides of R, S, T. All right. So the length of the sides of R double prime, S double prime, T double prime is 3 times longer than the length of the sides R, S, T, because the scale factor is 3. So the image is 3 times as long as. So you could. The second one, we could use area. We could simply say the area of R double prime, S double prime, double prime is 9 times the area of R, S, T. So we could just use those ideas and walk ourselves out of that. All right, I trust that this would have helped you somewhat. Please like, subscribe, and share. Also drop a comment at Dilemmas Concepts.